Hello, welcome all of you in the practical demonstration. Today we will see acid-base titration, aim of the experiment, prepare 0.1 normal NaOH solution and standardize by using given oxalic acid solution. Apparatus required: pipette, burette, conical flask, wash bottles, funnel, volumetric flask also known as standard flask, analytical balance and weight box. Chemicals required are 0.1 normal oxalic acid solution, NaOH flex, phenolphthalein indicator. Reaction can be quoted as 2 NaOH when treated with C2O4H2. It gives Na2C2O4 plus 2H2. That is sodium hydroxide when treated with oxalic acid. It gives sodium oxalate. Theory behind this: a standardization is a technique of finding normality of a secondary standard substances like NaOH HCl with a primary substances like oxalic acid by titration method. In this experiment, 0.1 normal of sodium hydroxide solution is prepared and it is titrated with a standard oxalic acid solution, and the exact normality of sodium hydroxide solution is determined. Procedure: in first part we have to prepare 0.1 normal NaOH solution. Weigh accurately 0.4 gram of NaOH and transfer to beaker containing about 50 ml of distilled water and stir well. Transfer this NaOH solution and washing to 100 ml standard flask and dilute to the distilled water up to the mark. Shake the flask through mixing. In second part, standardization of 0.1 normal NaOH solution. Rinse and fill the clean burette with this prepared 0.1 normal NaOH solution up to the 0 mark. Pipette out 10 ml of given standard oxalic acid solution in a clean conical flask. Add 2 to 3 drops of phenolphthalein as an indicator and titrate against 0.1 normal NaOH solution till permanent faint pink color appears. Note the burette reading. Repeat the titration until constant readings are obtained. Observations are: solution in burette, 0.1 normal NaOH solution, solution by pipette, 10 ml oxalic acid solution, indicator phenolphthalein, end point colorless to faint pink. The exact process or the setup can be like this. The burette is attached to the clamp stand above the conical flask. The burette is filled with the solution of NaOH prepared in the standard flask. 10 ml of oxalic acid solution, pipette out and transfer into the conical flask. Prepare the number of flasks to repeat the test. Last, an indicator of phenolphthalein added to the conical flask. The process of titration can be like this. So read the initial level of the liquid in the burette. Turn the tap to start pouring the liquid into the flask. Shake the flask continuously. When the indicator begins to change the color, slow the flow. When the color changes permanently, stop the flow and read the final volume. The volume change need to be calculated, that is initial volume minus final volume, that will be the burette reading, and record it in the observation table. Repeat until we get the three precise result. Minimum 3 titration should be noted. Those are recorded in the observation table. Observation table is like this: serial number, burette reading, that is initial burette reading, final burette reading, and difference of these final and initial, and mean burette reading, that is also termed as MBR. In the calculation part, first we should calculate the mean burette reading, that is MBR, from the 3 titration that we have get. For example, if we got 3 titration readings like 10 ml, 10.1 ml, 9.9 ml, then the MBR can be calculated as sum of these titers divided by number of titers, or this will become 10 ml. This is the MBR. This is the example only. In the calculation part, that is to calculate the normality of a sodium hydroxide solution, it is NaOH corresponds to oxalic acid solution, that is N1 V1 equal to N2 V2, where N1 is the normality of NaOH and V1 is the volume of NaOH, and N2 is a normality of oxalic acid, V2 is a volume of oxalic acid. We know we have to calculate the normality of NaOH, that is exact normality of NaOH. Volume of NaOH is a burette reading, that is a mean burette reading that we have got in the titration experiment. N2, that is normality of oxalic acid, is a known, that is given 0.1 normal, and V2, that is volume we have taken by pipette of oxalic acid, is 10 ml. Once we know all these value, we can calculate N1 very easily. N1 is equal to 0.1 into 10 divided by MBR. If we know the MBR, we can calculate the N1. For example, if MBR is a 10, then N1 is equal to 0.1 normal. In the second, to calculate the strength of sodium hydroxide is equal to N1 into equivalent weight of sodium hydroxide. For example, if normality of NaOH is 0.1, then strength of NaOH should be equal to 0.1 into 40, that should be equal to 4 gram per liter. Finally, we should quote the result in such a way that normality of NaOH is equal to dash dash normal and strength of NaOH solution is equal to dash dash gram per liter. Hope you understand. Thank you.